Hello, welcome everyone, welcome back, and now we will take a look at the task number 1 pair difference of week 86 of the weekly challenge. It's not per weekly challenge, I will repeat it every time. So the pair difference, so what this is about, you are given an array of integers and an integer a. Write a script to find if there exists a pair of elements in the array whose difference is a. Print 1 if exists, otherwise 0. Okay, so there are some numbers, some integer numbers. There's $a, which is 7, and we have to find out that there is a pair here, like 15 minus 8 will be 7, and then we print 1, and for this case the difference is 15. Yeah, definitely all the numbers end with a 0, so yeah, we don't have any numbers matching this difference, right? Okay, so sounds simple, and let's look at the solutions. So solutions of week 86. And okay, so Raku solutions. Okay, my solution is first, not surprisingly. And by the way, notice that there are many missing solutions of the task number 2, right? Because yeah, it was a Sudoku search, Sudoku solution, solving Sudoku, and it's kind of difficult thing. Okay, so yeah, so the numbers, right? So here are the numbers, and here is the difference. And what I'm doing, yeah, I created this one-liner, but actually probably it's a bit too complicated, but yeah, it solves the task definitely. So what I'm doing here, I'm taking all the possible pairs, so all the combinations. So basically, I just pick all pairs that I can pick of 2 elements, and then I map all those pairs into the difference, right? So, and this is a very interesting case where dot before the index is a really good thing. So yeah, I can omit $_ and I can just put this dot here. In all other cases, as Mohammed likes to do it, like here, the method call, yeah, you can put like $a or even at n dot square brackets 1. That's fine, but yeah, but actually why? But in this case, where we don't have this $_ explicitly written down, it's fine. Okay, definitely want the absolute value because yeah, we don't know which number is bigger. And after that, if any of those combinations mapped to the difference are equal to a, yeah, we're done. So if we found this, we can print 1, but just to print 1, not true or false, I'm converted it here explicitly to a number. And so is the, actually probably I can put the question mark here, right? Kind of. So, but so it basically gets an Boolean value out of its argument. Okay, all right. So let's Raku. Where am I? Raku #Raku chair 1. So I have all the numbers built in, and it prints 1, which is correct. Good. Okay. But yeah, on the other side, so we don't have the second task here, but we have the new name. Yeah, at least in this series, Raku number 1, because the task 1 is quite simple. Right, so here's the solution. So what we have here, we take some numbers from command line, which means that I want to copy some of them, probably before going further. All right, and after that, so we take those arguments and fill $n with them, and we also take, the first of n as the a. Okay, and then solve it. We pass it to the function, and integers list is immutable, so sort every time. What do you mean sort every time? It's only called once, right? Right, so there are some test numbers basically, which are the input numbers sorted, so we know that low numbers go on the left. Then we take the high, pop what is high, R value, and for all those numbers, R value is 1 if the difference is, okay, so yeah, okay, and then we, this is why this comment here, because we are solving this task recursively. So we take the first number and we try to find all other numbers, right? We just, yeah, because this high is basically the test number, the main number against which we test the difference. We remove it from the array, so we scan all the others, and if we found something which gives this different, we break the loop, and if R value is not the test, no, wait, if there is no R value and there is something here, what if it's 0 there? Actually, probably it's kind of test.elements, right? This is what I think it was meant here. The number of elements, basically, if this array is empty, then we recursively call the same function, but with already a bit smaller array, right? With the integers without the first number. And after that, so if we found it, we print the number and we return from else. Okay, right. Okay, nevertheless, we can run it, right? Raku SWA, right? Raku 1. And I have those numbers. I have to remove commas and I have to put the difference, the expected difference, if I'm correct at the beginning. So yeah, there is 1. And for example, if I will have like 77, definitely it's also 1, right? Okay, why? Actually, who is printing this one? This one, right? If difference, but it's not. Wait, okay. Let's just 56. So it's oh yeah, it's not shift, sorry, and actually here it's not the first one. Okay, yeah. So actually 7 should be, yeah, because also there's the pair of numbers like 10 and 15, which has the difference of 7, and 77 will be incorrect. Okay, good. Right, going next, Feng chunk, Raku number 1. So we start here with the main function, and actually, yeah, the main function is quite short, but yeah, there's another bigger function about the usage, which is good. We can just copy some numbers from here. Yeah, and see here the difference comes first. Right, nevertheless, so yeah, it sounds like resembles my solution. So we take all the combinations, and where does this any parenthesis ends? Well, I believe here. So this is one thing, right? Why? Okay, after that, so I don't quite understand why we need any here. Any of those combinations, just probably just to apply, but yeah, it's apply this grep to everything, but it will be applied to everything if we don't have this any, right? Okay, grep. Right, so the difference, the absolute difference is the absolute, basically it's already positive, I believe. From the definition of the task, it's not explicitly said, but yeah, I think it's expected to be positive. But nevertheless, so this is here, and if there are some elements here, we print 1 or 0. If not, then we print 0. Okay, Raku Feng Chang Raku 1, and some numbers, these numbers, and 7 before. And for example, if we have, actually I have 56 because there is some difference. Which difference? Yeah, because this is like the number. Okay, so yeah, it works. Right, going next, and Jan Krnavik, let's see how he solved this problem. Alright, so we start here. Where do we start? So this is for test cases, and this is the user interface. So pair difference, and so yeah, as you see here, probably it's so it returns actually not just 1 or 0, it returns the pair of numbers which give this difference, right? Which is good. Interesting. And actually here we see the negative test with the negative number, and actually it works, because absolute is here. But okay, so this plus so this is what we saw in my solution, and so it's good that I started to review these solutions with my solution. After that, we call this pair difference function with 2 arguments. This is maybe not very like everybody will agree with this call of the function with more than 1 parameter without parentheses, but nevertheless it's completely fine. And this is what we have here. So we have a as the number, the difference, and the n. I don't know why we need n here, actually, because we're not going to pass sub arrays there, but nevertheless, so we take n if it is there. So actually, if there are some elements, then we do combinations, and if we got those combinations, obviously we could get there. No, probably not obviously. If there's only 1 element, and then we could not get any combinations of 2, right? But okay, and we take the first combination, this is why we can just compare the result with the pair, so it's a good solution in this sense. And those where the difference, again, you see, notice these dots in front of, well, actually after the, in front of square brackets, but after the invisible $_ is absolute difference, right? Okay, so Raku, Lambash, Raku, let's just run it with built-in tests. All the tests pass, including the test where we cannot find any difference, so which is good. Kangmin Leo, Raku number 1. So here's the solution. So it starts here. We take the first element of the command line arguments and we convert it to number. After that, we take all the rest and convert them to numbers as well. Good. And this v2, there are two numbers, right? So the first version 1 is similar to what we saw just in the previous solution, for example. So we take the combinations and we take the first number where, where that's the pointer block, the anonymous function, which takes the array, well, obviously of two elements, right? These two elements go into combo. And yeah, that's good. I like this solution because it uses this reduction operator with minus. Yeah, of course, there are only two elements here in the combination, so probably we didn't actually gain a lot chart sense-wise, right? But it looks interesting. So yeah, we take the first combination. So yeah, actually, we take the first combination and actually we return the combination. So it's not just 1 or 0, it's a combination. But version 2 is a bit different. So we take the difference in the array and we keep some positions probably. So what we do here, so we fill the positions, right? So N is an array, so KV gives us the sequence of pairs where the first element, the key, is the index of the element and the value of V is its value. So we push, so K and V, key and value, right? Pause at, why we haven't push here? Because it's only one time assignment, right? Okay, so yeah, basically it's kind of inversed. So we've got the value and we can understand at which position this value is located in the original source, data source, right? After that, so we take, so we try to find the first value from the source data where this value, right, plus some difference, interesting, exists, right? So if basically we can find the value which is bigger by the current number by this delta, which is $A, and if it is there, if it exists, or the same with basically with minus, because we don't know which number is bigger, then we are good. We found this solution. Okay, that's an interesting solution, definitely. And right, so Raku Gug Raku chair 1, and I believe we need, here the first number is the difference, right? And if I will remove all these things, it gives us the correct solution 1. Okay, but actually this solution has a potential, because if you will just basically remove these, right, we could print the pair, which gives us the difference, which will be a good addition to the output. Mark Anderson, Raku number 1. So the main function and another main function. So there are two multi-versions of the same function, of the main function. And which one? Yeah, this one is where we can enter something from command line, and this one just runs the tests. And this function, pair diff, takes the difference in the array. It converts the numbers to bag. That's a good thing, probably because, again, so we are immediately kind of get the hash. Like in the previous solution, we were creating the hash manually, but here we get this hash behavior. Actually, it's a bag. And we also eliminate the duplicates from the command line. Actually, again, it's not stated in the definition of in the task, in the description of the task, but yeah, why not? So we've got those numbers as a bag, and if this if the difference the expected difference is 0, so basically we have to find the duplicates, at least one duplicate, and then we return values first from that bag with the counter basically bigger than 0, right? All those conversions to Boolean and back to integer. That's a bit annoying, right? But the task requires this. And otherwise, basically the difference is non-trivial. Then we scan the keys, and the keys are the number of repetitions. Wait, no, I'm wrong. These are values, right? The keys are basically the values, unique values from the input, and we return 1 if this number exists, right? And because we scan all the numbers, we don't have to, actually probably in previous solution but nevertheless, so yeah, we don't have to put minus here because we will find this number in any case. Right, so okay, so let's just run this with Raku, Mark Anderson, Raku 1. Let's run the version with the tests, and here we are. So which are the tests? The tests are those from the command line. I only don't think that I see. Okay, so yeah, okay, not okay. Okay, so yeah, these two examples is where we found some two elements which give the difference, and this is the option that doesn't work that way. Okay, good. Philip Hood, Raku number 1. So we take the arguments where all of those are integers, and we take the first, actually no, again, the last of them. I really don't like this pop and shift, because I have to like build the memory, the construction in my mind to understand how it works, right? So I can say, would it be like first, like actually in one of the solutions we already had, which is I think a better name for this use case at least. But nevertheless, so yeah, we just remember that the difference goes in the end. And res is the array that we are going to gather from. So we're taking actually these two elements, right? These two elements, and what do we here? So we've got, oh wow, we've got all the permutations, and we fail this H array, %H array, two-dimensional hash, sorry. On the first element, so basically it's kind of a multiplication table, right? Composed of the numbers from the input source data, right? So we fill, basically we kind of count the number of such pairs. Basically all these two elements represent all the potential pairs, including those with 0 difference, right? Because like permutations, will it give us the same element twice? Probably not, right? Okay, probably excluded, but nevertheless. So, and after that we scan all those things. This is the two-dimensional hash, so we have to organize a couple of loops, and if the difference between these two basically keys, right, of those two layers give us the difference, then we take it. The only thing I don't understand why. Okay, so probably we can optimize it a bit, because here it looks like if we have them in different order and we don't have apps function here, we could skip them and we can find them in some like mirror reflected position of this matrix, right? But we will find it. After that, if there are some elements, we just make some output. And this output is rich, because we not only print 1 or 0, but we also explain, right? And actually it will find all the solutions, right? It looks like, so it will list more than one solution, which is also good. Okay, right, so Raku PKMNX Raku Ch1, and we need the same thing with the number of with difference at the end of this data array. Okay, so here we see the example where we have two combinations like that, and for example, if we demand like 71, definitely 1, and what if we like break this 15 and convert it into 16, we will have only 1, right? Okay, good, really good. Going next. The next solution here is the solution by PJ Durai, Raku 1. So what we've got here, we've got the main function with 3 tests. Actually, they are all okay, but you see, here is the test, right? So yeah, probably we can test it like in one of the previous solutions with not okay, but why not? We can do it like this. And actually we print what we expect. Right, and the solve function, so we take the combinations of 2, and then we have this pointy block as the body of the for loop, and we take those 2 elements from the combinations list, well, actually the sequence, into this pair, and return 1 if abs of these differences is the difference. Right, so Raku, BJ, Raku, Ch1, some tests, and they all pass. Simon Proctor, Rakulang 1. So submain, we take the difference, and it is followed by some numbers which are all integers. First attempt. So yeah, that would be really great attempt. Any of these minus any of these is A. Probably any should go around. Yeah, I like the kind of the idea behind this, but probably doesn't work. But nevertheless, this is about twice as it's not just yeah. So but so it works, right? So yeah, definitely. Wow, twice as fast as dealing with long lists. Any of these okay. So the idea here is a bit different, because yeah, we try to create this kind of multiplication difference product, difference table, right? Using this cross operator X with the minus. Yeah, that's cool. That's yeah, I like both of them. I really like both of them. I don't understand. I mean, I wouldn't come up to write down these solutions, but I enjoy when I see such solutions. So any of those. So we build the table with differences, and if any of those basically is A, right? Yeah, then we print 1 or 0. Right, okay, Raku, I like it. Raku, Simon, Proctor, Raku, Ch1, Raku, and we need these numbers here, right? Yeah, so it's 1, and for example, if it's 8, it will be 1. Oops. Yeah. I mean, this is 1, right? Okay, good. So yeah, it works. Stuart Little, Raku number 1. So here's the solution. So the rest is diff pair of arguments. The first argument, the first value, and the rest converted to integers. And we've got those combinations. We map them to, what do we map them to? We map them to this construction. Okay. So this construction is basically the pair, right? The combination of 2 elements, and the same elements repeated in a separate construction, right? We map them to flatten everything, and if this, yeah, this is where we're trying to find the difference. I don't quite understand why we need this, but basically, yeah. And after that, if there are some, we print 1, and we also, because we return the what do we return, the first basically combination. I don't understand why we need these, right? Why cannot we just leave this and put abs here? It will be the shortest solution, right? Okay, but we have to run it. Raku, Stuart Little, Raku, Ch1. So the first element is, where is it? It is the difference, and the rest are the numbers. Yeah, cool. Yeah, it gave us, so if we will have like 17, it's 0. Good. Okay, going next. The next solution that Arne Sommer gave us. Right, Arne Sommer. So we take everything from command line, and there are some restrictions, like all of those should be integers, and there should be at least 2 elements in their data list. Notice. So you see, interesting thing, and yeah, this star is important here. So yeah, again, this plus so of any combination of two mapped to, yeah, the difference. Yeah, this is again a really interesting thing with reduction operator and apps, right? The only thing probably can be, yeah, probably you cannot avoid this $_ here, because okay, but nevertheless that's an interesting task, how to apply it to default variable in this map, right? Probably we can put star here or not, I'm not sure. Actually I tried, but something kind of didn't work. Okay, yeah, if any of those is 1, yeah, so see, notice yeah, that this equals $A goes, well, actually, or is applied. So basically we compare A with the result of any and not with the result of this absolute difference inside the map. So we see, so you can put it here, but you can also put it outside. If you put it here, actually probably we didn't need any. We can use grep, right, after that. But actually no, actually we can use any as well, right? Yeah, probably any would be simple. So, but that's the magic. Any is one of the most magical thing, I think, in Raku. These junctions, any junctions, and all junctions, they're cute. Right. Okay. So we can run this solution. Raku Arner Soma Raku Che 1. So the first number is the difference, right? So it's like 7 and the rest, and it's 1. And if it's 77, then it's 0. Good. Athanasius Raku 1. So you, right, so Perl Weekly Challenge, why is it Perl? 86, so where's the main function? I'm trying to find the main function. So the main function takes the number and it's required, yeah, that's cool. Exclamation mark demands this variable to be there. And after that we expect at least 2 integer and defined numbers, actually data, and right, so the words I cannot read. Find pair. So these values we pass, wow, to function find pair, and this loop. So we loop. So the $I is an index. So basically we loop this twice, right? And on each, yeah, again, so we'll build in the kind of table of differences, and if this difference is either A or minus A, we fill those 2 variables that we're going to return as a list with the values based on the counters, right, in these loops. Yeah, here are the values, and we end the loop, right? Actually, we can return, but yeah, because we are going to return something and we don't want to repeat it twice. Actually, yeah, last out 4 is repeated twice instead. But yeah, that's okay. And after that, so if we have those 2 values, right, so yeah, we just print those values as this, but we only find the single solution, right? So yeah, if there are like 2 solutions, right, like we saw earlier, like here, for example, we will not find it here in this program, but it's not required actually. Athanasius Raku Che 1, Raku, so 7, and the rest, right? No, not that easy. Not that easy. Not that easy. Yeah, but the result is correct, and if it's like 71, for some reason it was 71, right? So it's 0. Okay, good. Colin Crane, Raku 1. But no Raku 2, and so there's this difference with some default value, and after that we have some input. If the number of elements in the data, so yeah, I was trying to read it first, but then I realized that actually this is the substitution of some default values. Interesting. So yeah, so what we do, we sort those, we take the combinations and we map those to these difference. Probably sorting allows us to make this difference non-negative. It can be 0, but it's not negative at least, because yes, its first element means 0th element. And after that we grab this map to find the values with the difference we expected, and if there are some elements we print 1, otherwise we print 0, which is quite clearly understood what we are doing here. So right, so we need target and some data, and it's 1, and let's break this nice thing. Yeah, it prints 0 as expected. Really good. Jaldar Vyas, Raku number 1. Right, so again we take some numbers. The first is the difference. We take the combinations, we grab something new. So we grab and we okay, yeah, so this dollar underscore is an array of 2 elements, right? Of 2 items, which are the elements of the combinations of 2 elements. And we, so that to avoid apps or to compare with minus a, we just take the maximum of those and the minimum of those. If they're equal, yeah, we will definitely get 0, and a should be 0. And again, if there are some elements, we print 1, otherwise we print 0. Right, interesting. Raku, Jaldar, Vyas, Raku, 1, Raku, 7, and the rest, 7, 11. Right, so let's make it 11. It's 1, and where are we going? So it should be 9, right? It's still there. Right, because it's 12 and... okay, let's make it 13. Right, it's 0. Good. Huledi Castro, Raku 1. So there are some tests, and this is what we do, but we also have some arguments, right? So we will first execute the program. Actually, yeah, and exit, and if there are no elements passed, we'll execute these tests. Right, so say diff pair of first argument and the rest, and the first being a difference probably, and what is I? Yeah, because we are going to call it recursively with an increment in I. That's functional programming style, that's interesting. So we return 0 if $i is bigger than the number of elements, actually bigger than the last index, right? And return 1 if starting from this position $i until the end of the array, there are something. Yeah, actually grep can be replaced with there are, or there is for first, right? There are elements which give us, no wait, $_ okay, yeah. $_ is the element itself, and $i is an index, and we take this value at this position. So okay, so this is where we scan the array, and we compare it here with the single. No, not with the single, was actually with all those elements here. So it's the second loop, right? And if we found this difference, we return 1. Otherwise, we continue, but we take here the next element, right? So we compare all the elements from the right side, from the right of this element with this element. Okay, yeah, I would say it's complicated, but I believe it works. Julie or DC, Rakuchi 1, so first element is 7, and then the data, and let's break this, and it's breakable. Right, so yeah, it works, so the solution is correct. Okay, Lauren Rosenfeld, Raku number 1. So there are some tests built in, and we are iterating over these tests. Yeah, again, so yeah, always I will, yeah, because I really enjoy this bit, that in the loop you can just take the array. Here you are. So, and the array actually is the target, the first element, and all the rest is the element at the first position, right? So this is R1. If R1 combinations of 2, and we loop over those combinations, which are called candidates here, and we report that it's found, and say candidate, so, and actually we also print, yeah, so there are not that that many parentheses here, and say candidate and last. If, right, so yeah, wow, that's cute, that Raku understands this construction. If this absolute difference is the expected value, and after that, so is, yeah, okay, so first we will, actually we break the loop here, so we'll again only print a single solution, but if probably we'll avoid this, and last we'll find all the candidates, right? Right, Raku, Laurent Rosenfeld, Raku 1. Yeah, so yeah, there are only built-in tests, and I believe everything works. So yeah, here is 0, right, and all the rest is here. Yeah, and here we indeed print the first found solution. Right. Okay, Myunjin on Raku number 1. So we take the numbers, sigilless variables from command line, and they all should be integer, and there should be at least one element. Actually, this dot is applied where to? Probably to this one, right? Well, definitely to this one. So we do not restrict A by this, but we do restrict it by here, by this type reference, right? Right. Then we saw the elements and we loop over them. You see, so we do not increment I in the loop, we do it here. Wow. So okay, so we start this potentially infinitely long running loop. Then if the difference, what is it? Is, what's that? It's wait. Raku, docs Python, Raku. It's like less or more, right? Numeric three-way comparison to real, and then does the numerical. I forgot about this operator. Yeah, but yeah, definitely yes. So yeah. But why do we need it? So if it's less, if this element is less than this element, if this difference is less than the expected difference, then we increment the counter and we move on to the second element. And okay, so yeah, this difference is always about the difference with the first element, right, of this $n. But we made this $n a copy of the original data, and actually if this difference is like gives us more, then we remove the first element of that difference, and basically this at n0 becomes the second element, and we put this to the first element, and yeah, this is how we iterate. Basically, yeah, this is how we organized a couple of loops inside one loop, right? And after that, if basically they are equal, which is default, then we are saying one is, yeah, and show the difference and stop the program. Right, exit 0, exit 1. Okay, actually I don't know if it's exit 1, because yeah, it's an expected solution. In any case, it's not a program error, but yeah, okay, that's fine. It depends on how you define this error. Raku 1, so what do we need? We need some 7 and some right, so we need some these. No, we need these, right? Right, one is this is, and so probably it should print just 0. Good. Okay, Roger Bell West, Raku number 1, and there's one solution left after that. So there are some tests with both classes of test cases with 1 and 0. So sub PD, guess what it means? So we convert the number to a set, the list of numbers to a set. After that, so we map that. No, so for, what do we map actually? I don't understand. So we map $_, what is $_ here? I understand the idea, but I can't read it. So we map for map. Yeah. So this map is kind of should be gathered together, but actually this absence of the space of the comma makes me feel that this is the single construction. Okay, so now I understand it. So we map over, we map those keys, right? Basically we map the unique values, input values, to the difference, right? To the sum of the difference and the element. Whew. And if this element exists, so basically if we found the second, right, so yeah, so if basically here we kind of think that if this $_ is the minimum element in this pair, which gives us the difference, then this actually should be the maximum element in that pair. And if this element also exists in the data set, we print 1. The only thing I expect, what if, for example, the difference is 0 and we do not have any duplicates? We probably should print 0 in this case, but I believe this one prints 1 because this element exists. But this is the same element and we need another element, right? But okay, that's it. That's, I think, a bit beyond the task. So, but the obvious thing that it's probably just gives the correct result. So there are some built-in tests, they all pass. Right, and the last solution here on this list today, so it's Ulrich Rieker. And Ulrich gives us this. So we take some right, so we enter an array. To finish input we need to type -1, but this difference comes from command line after that. So we've got this array and we sort it decreasing. Probably we can use reverse instead of this. Right, and we take the combinations of 2 and this combi, and we take the difference, and yeah, probably by sorting we make sure that this difference is always positive. Output is 1 and we break it and we print output, and otherwise we print this 0 from here. Right, so Raku, Ulrich, Raku, chair 1, and we need the difference here in the command line. After that we're entering 10, 8, 12, 15 and 5 and -1 to finish, and it's 1. And yeah, so it's a correct solution. Okay, that was it. So yeah, there were quite a few solutions today. So it was the week number 86, task number 1, which was, what was the name of the task? I forgot. So yeah, about the difference of numbers, pair difference, right? So that's it. So yeah, there's another one, Sudoku. I'm not sure that I'm going to review it because yeah, I expect that solutions are quite complicated. Yeah, I see so many people skipped this. Well, yeah, it's still interesting, yeah, Raku-wise at least. Okay, so let's see. But nevertheless, so thanks for watching, and I hope you enjoy Raku actually, at least. Okay, goodbye.